Welcome back to physics, everybody. Here's a sort of entry-level projectile motion problem involving two dimensions, horizontally and vertically. Bonus marks if you can remember which film this shot is from. Robin Hood is firing an arrow horizontally at a target that is 25 meters away, and the arrow flies at 60 meters per second. The center of the bullseye is 1.4 meters above the ground, but the arrow is released slightly higher and will accelerate to the ground. G in this case, obviously, with IB physics, is 9.8 meters per second. And the bullseye has a diameter of 20 centimeters. So you've got a bit of leeway there, 10 centimeters above, 10 centimeters below, in order to hit the target. How long does the arrow take to hit the target? And determine if Robin hits the bullseye. Okay? So, if you want to figure this out, pause the video now. If you want to see the solution, carry on. So once the arrow is fired, it's going to accelerate towards the ground. The longer it is in the air, the longer it will accelerate. So given that the target is only 25 meters away and it's traveling significantly faster than that in a second, then the initial problem isn't so bad. It's just displacement equals velocity times time, all only horizontally. So it's going to take 0.2 seconds to hit the target. So it's only really falling for 0.2 seconds. Given that acceleration due to gravity is 9.8 meters per second, therefore it shouldn't fall very far in that time, but we want to check if it falls the right amount. So how do we do that? One of the best equations for this, once you've got all your given material here, all the given numbers you have, is this equation here, S equals ut plus a half at squared. Notice that in this case, there's no change in direction. The arrow is simply going to accelerate downwards, so it doesn't matter in this case if we use minus 9.8. All right, so just keeping it positive is great. Now, because its initial vertical velocity is 0, that gives us a little bit of an easier way to solve this equation, because the first term will cancel. Okay, and we know that it takes 0.2 seconds to hit the board. So if that first term cancels, everything becomes an awful lot easier. This means that in the time that it flies, the arrow is going to drop just over 19 centimeters. Quick bit of math, we can figure out that if the minimum fall to hit the bullseye is 10 centimeters, the maximum would be 30 centimeters. So Robin is going to hit just north of the bullseye. Well done, Robin. In case you were wondering, the opening shot of that slide, the first slide you saw, was Robin Hood, Prince of Thieves. There you go. Classic Kevin Costner.